Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will discuss about the defect in metal casting process. Now there are different types of defects that appears in the casting, and we have to consider all these defects so that we can able to uh, have a defect-free castings. Now one of that is that blow, we call it blow, another is scab, blister, pinholes, porosity, drop, inclusion, fins and flash, scab, penetration, swell, misrun, cold shed, hot tears, shrinkage cavity, and mold shift. These are the few one which is being enumerated over here. Now the first one is a blow, or we call it a blow hole. Now this blow is actually appears like a fairly large, well-round cavity. Usually occurs in a convex casting surface at the cope. Uh, the causes may be improper venting or inadequate venting, and therefore, keeping this view, we have the remedial process is that we should have a proper venting or adequate venting. We should try to control moisture content in the mixant and control volatile constituent in the content in the sand mix, so that they may not appear as a blow or have a blowhole. Now another is a scar. A scar is basically appears as a shallow blow round in flat casting. It appears in flat casting. Blowholes on the top surface, of course, it may just have a swell out, but this scar appears in a shallow blow. It is a type of shallow blow found in a flat casting. Now the causes may be improper venting, inadequate venting, and therefore the remedy accordingly should be proper venting, adequate venting, control moisture content, and volatile constituent as it was there in blue. The similar type of casting is there. Now this is a blister. Now the blister appears as a scar, but covered by a thin layer of the metal. Now this again due to improper venting or inadequate venting. Now maybe the same remedial process, but that means proper venting and controlled moisture content and controlled volatile constituent in the sand mix. Now the pinholes. Pinholes are the small holes dispersed in the casting surface, below that surface of the casting, and it is normally uniformly distributed. It is uniformly distributed. The cause can be the same one, improper venting and inadequate venting, and therefore we have to have a proper venting and the mixture constituent and volatile constituent in the sand mix should be properly controlled. Then comes the porosity. Now you can see the difference between the pinhole and the porosity is that porosity is is closer to the surface, while porosity is distributed throughout the casting. The same type of thing, but it is being distributed throughout then we call it a porosity. And the causes may be decrease in gas solubility during solidification, gas solubility in this, and therefore, keeping that in view, we can avoid by avoiding the aspiration effect and designing a proper gating system, we can overcome this porosity. Then there is a drop. Now basically this drop may appears as a irregular projection on the surface of sand, as we have seen earlier in the figure. Now, this can be pieces of metal dropped into the liquid metal, and it occurs when ramming is soft and there is no, or there can be no proper enforcement of the sand projection if they are in the cope. That should be properly reinforced, that so that it may not drop, allow the uh, metal to drop on the liquid metal. And therefore adequate ramming, proper fluxing of molten metal, and adequate reinforcement of sand projection on the cope will of course avoid to have the defect like drop. Now another comes the inclusion, inclusion, inclusion of sand particles. These are the inclusions. Inclusions are there. The inclusions are there. Now here I can see the inclusions. Now they appears as not non-metallic particles in the metal casting. Now it occurs when the sand molds are the sand is loosely bounded with metal, and therefore it may occur due to turbulence during casting, or the ramming is soft, or the generally in die casting we spray metal on the surface of it. Now if this spray is not properly sticking to the adhering to the wall of this, and that may get drop into the and have the inclusion. Metal practice preservation. Now basically it happens that the metal particles, when they solidify premature, then this may cause the particular type of inclusion. Now therefore adequate ramming and non-pressurized laminar flow, but we can have a laminar flow, and non-pressurized flow will of course avoid the inclusion of foreign particles in the casting. Now there is a fins or flash. You can see these are the fins, come out some molten metal and get solidified. The fins are there. Now this may be due to the appears as a thin projection of metal usually occur at the parting line. Now maybe inadequate weighted sand. The sand is not properly weighted, and therefore over flexible bottom board may also cause to the mold to sink and then give the fins and flash. Defective mold box or loose plate and improper clamping of the flask may also cause fin and flash. And therefore the molds and cores should be properly assembled. If the weight of the cope is low, then the buoyancy force of the molten metal, then we provide a proper weight on the mold block so that it may not lift and have the fins and flash. And change the defective, if there is defective flask, that should be changed so that the fins and flash may not appear. Now the scab is very similar to the blood and all that, and therefore this can be, you see, appear as a rough thin layer of metal floating above the casting surface, just above the casting surface. The layer of metal you might have seen appearing on the casting, that we call scab. Now if the sand grains are very fine, then they penetrate into the fine grain sand and form this scab. Or using sand of low permeability, this will also cause the material to get into and have the formation of the scab. Or uneven ramming, it is not properly, and therefore the soft corner, the soft place, locations will allow to penetrate the molten metal into the sand particles, and therefore uniform ramming, pouring with correct velocity will avoid turbulence, and then we can have get rid of this scab, mixing additive additives like sea coal, wood tar, dextrine in the sand. This also will avoid the scab, formation of scab. Now penetration. Now this thing, what happens that when the metal the metal get flow into the sand, and therefore they get penetrated, and therefore you see the place it appears like rough and porous projections in the cast surface, and if the metal combine react with solid with sand, then they give a rough and glossy appearance, and therefore it happens only because of too soft or porous mold or liquid metal flow between the sand particles into the mold, and therefore we can avoid it by having a adequate ramming. Now the swelling. Now this scab occurs on the top surface, top surface, while swell occurs on the side walls. Now this is enlargement of mold cavity by metal pressure. Metal is at high pressure, and therefore, if the ramming is not adequate, then this may push the wall and swell the metal out. And it can be localized, or it can be overall enlargement of the soil casting may take place, and generally it is found in a vertical surfaces of castings. Now causes: insufficient ramming of sand, rapid pouring of metal, insufficient weight of the mold, and hydraulic pressure of the molten metal, which is maybe due to the high moisture content, may cause the surfaces to swell into the mold cavity. Now, therefore, sufficient ramming, avoid rapid pouring, and proper weighting of the mold and adequate moisture content can be helpful to avoid this type of defect. Then therefore Misrun. Now you see this is the complete product. It is not being filled, and therefore we are having a Misrun. This can be due to the appears as the molten metal does not completely fill the mold, and maybe due to the insufficient metal in the pouring box, lack of fluidity of the metal, or insufficient superheat will also restrict the molten metal to flow into each and every corner of the mold cavity, and therefore sufficient metal in the pouring process and sufficient superheat will avoid the defect like Misrun. Now there is a cold shut. Now here the surface is coming over here, and there is a, you can see there the surfaces are not a proper mix, and therefore you can see that it appears like two metal streams does not fuse together. Now therefore lack of fluidity of the metal and insufficient superheat doesn't allow to melt the two metal streams and cause the cold shut, and therefore maintaining proper pouring temperature and modifying gating system, and that means having increasing superheat, etc., we can avoid the cold shut. Now the hot tears we call. After completing all these things, there can be stasis, and this may cause the appearance of the hot cracking. It may be, you see, hot crack. After filling, the material is hot, and the stresses developed may cause the cracking, or the material is not sufficient and get shortened, and therefore there can be hot shortened. Now therefore inadequate compensation of liquid shrinkage, high residual thermal stress will cause to have these cracks, hot cracks, and therefore avoid excessive ramming and controlled ramming, and we should have a controlled ramming. This will cause the removal of hot tears. Now the shrinkage cavity, You can see the shrinkage cavity over here. The shrinkage cavity over here is a very big type of the, you can see there are a lot of shrinkage cavities the top of it. That means the metal has not been properly filled to each and corner. See, it got the after reading solidification, the metal shrink, and therefore appears like a shrink cavity, and it is due to the inadequate liquid feed mechanism and also improper design of the riser, and therefore by having a proper efficient riser and such that the liquid metal under pressure should flow continuously during solidification, then only we can avoid the shrinkage cavity. Now, mold shift, it is also known as mismatch. Now that these two part of it, they are not properly aligned. They look like this, they are not properly aligned. Okay, and therefore, see, mold shift can be due to misalignment between two halves of the mass or misalignment of the cores also, misalignment of the cores. Okay, this will also cause mold shift, and the shifting of the mold flask and shifting the core will give the defect like mold shift. Therefore, you should use a proper mold box and use proper molding pin so that they should be properly aligned and there should be not the defect like mold shift. This is all about the defects, and if we avoid all these things, this is how then we can have a defect free casting.